Okay, I'm not sure how far you got in the problem, so I'm just going to go over the whole thing. So we have y equals x squared minus 3x plus 2. Our standard form of our equation is y equals ax squared plus bx plus c. So I'm going to identify all of our numbers first. A, if I have nothing in the front of here, it's 1. B is -3, and those negatives are important, and C is +2. The first thing we do is find our axis of symmetry. Which is x equals -b over 2 times a. So x equals -3, because we have negative in the equation and negative with our b, over 2 times by 1. So x equals 3 over 2. Those two negatives become positive. 2 times 1 is 2. So I have 3 over 2. The next thing we have to do is find our vertex. We use the x from our axis to find y in our equation. So I take this 3/2, I have to put it in. And if you prefer to write this as 1.5, so it makes it easier for you to do mathematically, and with the calculator, that's fine. So I have y equals x squared minus 3x plus 2, and I have x equals 3/2 or 1.5. So y equals 3/2 squared minus 3 times by 3/2 plus 2. So y equals 3 squared over 2 squared minus, and this becomes 3 times 3 on the top over 2 plus 2. So y equals 9 over 4 minus 9 over 2 plus 2. Now they are not in the same form, and I want them to be. So I'm going to take this 9 over 2, and I'm going to times the top and bottom by 2 so that my denominators here are the same. So I have 18 over 4. So now I have 9 over 4 minus 18 over 4 plus 2. So I have 9 minus 18, that's going to be -9 over 4. And I'm actually going to rewrite 2 as well. So if I times 2, top and bottom by 4, I'm going to get 8 over 4. So -9 plus +8 is going to leave me with -1/4. So my vertex is 3/2, comma, 1/4. It's not going to be a super fun one to graph, but we'll make it work. All right, so here's my graph. I'm going to actually go up here so I can look at my axis of symmetry first. So I have 3.5 or 3/2 or 1.5. So that's like here in between 1 and 2. So I'm drawing like a dashed line in the middle of that graph. That's my axis of symmetry. That's going to cut my parabola in half. And then I come down, my vertex is 3/2 negative 1/4. So that's going to be like here. We kind of have to estimate it. And now you were asking about the 2 at the end. So that 2 is our y-intercept. That is what C always represents. So C equals the y-intercept. So whatever our last number is, our number with no x, it's always our y-intercept. In this equation, C is equal to 2. So that means I have a point at 0, 2. So I'm going to go back to my graph, and here, 0, 2, I have a point. And because I have a point that is 1.5 in this direction from my axis, I have a point that's 1.5 the other direction from my axis. So you can mirror points, they are on the same place on opposite sides of the line. It has to be exactly even. And if I wanted to find another point for my graph, we could do 4, since that's the next number here. So we will find another point. Using x equals 4. So I'm going back to my equation and I'm going to put 4 in for x. So y equals 4 squared minus 3 times 4 plus 2. So I have 16 minus 12 plus 2. 16 minus 12 is 4. Plus 2 is 6. So y equals 6. So I have another point at 4, 6. So back to my graph. We're at 2. Here's 6 up here. So 4, 6. And since I have one at 4, I also have one at negative 1, 6. So mirroring it across, I have 2.5 here, and I have 2.5 here. There's my distance. Now I can draw a parabola. Something like that. And there it is. So if I'm looking at what that last number is in my equation, if there's no x with it, it's always c. If there was nothing there, then c is 0. And c represents our y-intercept in our equation. And the last thing I think you have to do for these problems is find your domain and range. So we look back at our graph. Your domain is all possible x values I could put in for this. And with a parabola, pretty much always with these quadratic equations we're looking at, x can be all real numbers. I can put anything in for x. The restrictions are on y. So our range, y, I'm looking at my graph, it opens up. That means all of my y values are going up. So they are greater than or equal to, and it's whatever this point was for our vertex. So if I look up here, that was negative 1/4. So for my range value, I can have any y value that is greater than negative 1/4.